Hello everyone. In the previous lecture, we discussed what is meant by the phase of an alternating quantity. In today's lecture, we will discuss what is meant by the phase difference. For this, let us consider three similar single turn coils which are displaced from each other by angles of alpha and beta and rotating in a uniform magnetic field with the same angular velocity, as a result of which EMF will be induced in all the three coils. The values of the EMF induced in all the three coils will be the same, but there is one important difference. The EMFs in all these coils do not reach their maximum values or zero values simultaneously, but one after the other. The three sinusoidal waves are shown in the figure B. So from these three sinusoidal waves of the coils A, B and C, we find that the maximum value of the induced EMF is same in each case, but the zero and the maximum values of all the three coils do not reach at the same time, but one after the other. It is seen from this curve that the waves A and B are displaced from each other by an angle beta, and A is displaced from C by an angle of alpha plus beta. So there is a phase difference between these three coils. So in this case we find that the value of the induced EMF in all the three coils are the same. The maximum value is also same, but there is one important difference, that the EMF in all these coils do not reach their maximum or zeros values simultaneously, but one after the other. The three sinusoidal waves are shown in the figure. From the figure B, we find that the curves B and C are displaced from the curve A by an angle of beta and alpha plus beta respectively. So this means that the phase difference between A and B is beta, that between B and C is alpha, but between A and C is alpha plus beta. And in order to show which alternating quantity reaches its maximum value earlier, we use the term lead. Similarly, to show which alternating quantity reaches its maximum value or zero value later, we use the term lag. So, a leading alternating quantity is one which reaches its maximum or zero value earlier as compared to the other quantity, whereas a lagging alternating quantity is one which reaches its maximum or zero value later than the other quantity. Now the three equations for the induced EMF in the three coils will be EA is equal to EM sin omega t. EA denotes the value of the induced EMF in the coil A. So EA will be equal to EM sin omega t. We have taken this coil as the reference quantity. Similarly, the EMF induced in coil B will be EM sin omega t minus beta. Minus beta means that the EMF of coil B is lagging behind A by an angle of beta. And the induced EMF in the coil C will be EC is equal to EM sin omega t minus alpha plus beta. We find that it is having an angle of minus alpha plus beta. So the EMF of this coil will lag the EMF of the coil A by an angle of alpha plus beta. Similarly, C lags behind B by an angle of alpha. So minus sign in case of an alternating quantity denotes lag, and plus sign in alternating quantity denotes lead. So these are the three values of the alternating EMF in this case when 3 similar single-turn coils are rotated in a uniform magnetic field. So we find that the coil B and C are lagging behind A, or we can say that A is leading B by an angle of beta. Similarly, A is leading C by an angle of alpha plus beta. So this is what is meant by phase difference.